Hi, everyone, and welcome to our symposium on examining TPACK in practice across teacher education. My name is Daniel Morlum, and along with Yijin, we'll be facilitating this symposium today. And our presentations that we have today, we have 4 of them, and they will be from beginning with Judy Harris and Jessica Duggan on conceptions of context in TPACK research. Our second presentation will be myself, on behalf of myself and Stephen Chestnut from the University of South Dakota on investigating differences in teacher candidate TPACK, comparisons of a STEM professional development school and a standalone educational technology course. Our third presentation will be by Yi Jin and Christy Harp on investigating middle grades pre-service teachers TPACK in a teacher education program. Then our final presentation will be by Teresa Folger on TPACK is throughout technology-infused teacher preparation programs. And to provide just a little bit of background as we get started here, we are living in a time where we have amazing access to digital technologies and media, but this issue that we have is that we struggle to effectively integrate them into teaching and learning. So much so that in the National Educational Technology Plan that was released in 2017, they called for better preparation of new teachers to take advantage of these digital tools that we have access to. So this begs the question then, how can teachers learn to teach effectively with technologies? And we are lucky enough to have a framework already kind of in place. It's been around since the early 2000s, really looking at teacher knowledge from a perspective of the overlap of technology knowledge, content knowledge, and pedagogical knowledge, and how that represents the knowledge teachers need to have to effectively teach with technology. Now, over the last several years, there's been a ton of research around how do we develop teacher, pre-service teacher knowledge, specifically around TPACK. And it's been categorized into really 3 different pathways. And the first one is we have standalone educational technology classes that candidates take during their preparation programs. But then we also have a number of different approaches that are using instructional strategies in content methods or technology courses, as well as instructional strategies implemented throughout teacher education programs. But a gap that still exists is really looking at, well, what is the process through which teacher candidate knowledge of content pedagogy and technologies are impacted, and what are the contextual factors that influence TPACK and the structures where it occurs? So our goals for today are really to conceptualize the various contexts within which TPACK development occurs and is expressed, and then to also present different approaches to TPACK development in pre-service teacher education. And with that, we'll go ahead and get started with our first presentation, which will be by Judy Harris and Jessica Duggan on conceptions of context in TPACK research.
Thanks, Dan. Jess and I are at William & Mary School of Education in Williamsburg, Virginia. And we took a look at the TPACK literature, the TPACK research literature, specifically articles and chapters that explore contextual elements. So to give a bit of background, we go to the next slide. TPACK literature has been published for about 15 years now, but it wasn't until 2008 when Mario Kelly in the first TPACK handbook called for more TPACK research that concerns contextual factors. Then in 2013, there was a very influential piece that was published by Porras Hernandez and Selena Semestua that linked TPACK contextual factors with a very popular theoretical framework, which we'll explain in just a moment, by Yuri Bronfenbrenner, to specifically help us to understand what we mean when we say contextual factors or contextual systems. Mike Phillips, in the next year, started his work that he continues even to today about contextual factors that are specifically around teachers' professional learning networks and how those influence their TPACK and the development of that TPACK. And then in 2015, Rosenberg and Kaler published a comprehensive literature review that looked at all of the TPACK literature that did address contextual factors up through 2013. But today, we're in 2020, so Jess and I wanted to find out what has happened in TPACK research around contextual factors that influence TPACK between 2014 and today. So to go to the next slide, what we noticed when we looked at these pieces between 2014 and the present day is that context could serve as a stated focus of a study, like the example that you see here, contextual factors that influence teachers' TPACK and therefore their TPACK in practice. But context, we found, could also be included in TPACK research in a way that doesn't necessarily use the word context. Things like, in this example, barriers and influences. Context can also be named in TPACK research in a way that doesn't really have anything to do with contextual factors themselves. So for example, like in this example where context is really used for as a general vocabulary word. So what we're doing, if we go to the next slide, is looking primarily at, exclusively, at these two, context as a stated focus and context as a focus, but not necessarily named in that way. So to go on, we think of contexts in a way, as you see pictured here, which we'll explain in just a moment. First, we'll describe Bronfenbrenner's theoretical frameworks to help us to understand the different kinds of contextual factors that can enter into all educational research, and in this case, TPACK research. So Bronfenbrenner published a lot of work about contextual factors, but he was not a researcher that literally looked at contextual factors in education. Bronfenbrenner was really concerned with human development theory. So he looked at context in an ecological way. He looked at the relationships and interrelationships between the developing person, for example, a child, the developing person, and multiple contextual systems that he called this. Bronfenbrenner's work actually changed a lot in the decades that he published about it until his death in 2005. The systems that TPACK research that references Bronfenbrenner uses are from his 1977 and 1979 publications, which we'll explain briefly now. Bronfenbrenner looked at systems, ecological influences, contextual influences, as being a set of interconnected influences upon the individual. The microsystem is the system in which the person finds themselves immediately. So that could be a classroom or a school or a neighborhood. What Bronfenbrenner called a mesosystem is actually the interrelationships of multiple systems. So while, for example, students learn, teachers teach in classrooms, they're also within the system of, for example, in secondary school, the department, within a school, which is within a district, which is within a geographic region, etc. Bronfenbrenner also talked about what he called exosystems, which were actually systems that have indirect influences on, for example, students who are learning in our classroom. So, for example, a student might have experienced a parent who had a stressful day at work. We've all had those, especially recently. That stress that the parent experienced in the work system or context then could influence their behavior when they came home to interact with the students, and the students then is indirectly affected by that parent's work system or ecosystem. There's also the macro system, which these are the larger cultural values and beliefs kinds of influences that are held typically by different kinds of groups, of which we are all of us are members of multiple groups. And then later in his work, Bronfenbrenner also talked about the chronosystem that has to do with time, especially socio-historical influence, contextual influences in the histories of, for example, marginalized members of marginalized groups. So now we'd like to share with you what we discovered when we looked at contexts in TPACK research that was published between 2014 and today, April 2020, specifically in articles and chapters. And Jess will share these results.
Sure. So we examined all TPACK-based studies that address contextual factors as Bronfenbrenner described them. And we coded them according to which of the 5 systems or contexts that they addressed. So the micro, meso, exo, macro, and chrono. We looked for frequencies over the 5 systems overall and over time. And we looked for co-occurrences of systems within the same study. So for example, one article or book chapter may be descriptive of multiple contexts. So the counts you're seeing are of the systems, not of the number of articles or book chapters read. Next slide. Visually, you can see TPACK research seems to have progressed over this 5.5 period. There is a dramatic increase leading up to 2018. It may be due to the sheer number of articles, TPACK related articles and book chapters published that year. But overall, you can see the growth in terms of the contextual research foci. And then overall, we looked at the TPACK articles and chapters about context throughout this 5.5-year time period. You can see to the top left, of almost 1/3 of the TPACK articles and book chapters discussed one or multiple contextual factors. And then in the bottom right-hand piece, you can just see the total numbers of those articles divvied out by year. Now, over the extended period of time, from 2001 up to 2020, we observed that the nature of teachers' TPACK and its correlates flow to the expression of TPACK in practice, to the situatedness of TPACK in practice, so influencing and then being shaped by the various contexts. We recommend that future research focus in on all 3 domains, moving towards the future.
So to continue our recommendations, we'd like to continue this visual metaphor that we hope that you've been noticing. You see a picture of a tree here that, at least at first glance, is quite attractive. But if you look more closely, you'll notice that this tree can't possibly exist in nature because it's a tree that's showing itself in all 4 seasons of its life. We are saying that if we try to make generalizable statements, generalizable results from TPACK research that looks at contextual factors, we're making a mistake. Because as was said a long time ago, in 1546, you can't necessarily see the wood or the forest for the trees if you focus too closely on the tree itself. We're suggesting instead that we look at each set of results from TPACK research that addresses contextual factors as those contexts change. In a way, what we're suggesting is that the results of TPACK research that explore contextual factors are more transferable in the way that Lincoln and Guba first explained this term than generalizable. There are definitely patterns that can be identified when TPACK research is exploring a particular contextual conditions in a particular location. Those can be applied to some extent to other contexts, but not necessarily in a way that's generalizable. At this point now, I'm happy to introduce again Dan, who will be presenting his paper that he prepared with Stephen Chester.
Okay, so I'm excited to present some research we've done around a STEM professional development school, and the title of my presentation is Investigating Differences in Teacher Candidate TPACK Comparisons of a STEM Professional Development School and Standalone Technology Course. So as we kind of talked about at the beginning, teacher candidates, they need to be prepared to leverage digital technologies and media through their instruction. And what we are doing at the University of South Dakota is we have created a STEM Professional Development School, or a PDS program. Now, before we get into what we're doing at USD, I wanted to just give some background on what a PDS program is in case you're not familiar with it. Now, PDS programs are a situated learning experience where candidates can learn from and through their practice. What happens in these partnerships is a local school and a university teacher education program really get together and they partner with one another to prepare both new and current teachers with the hope of improving student learning and increasing research opportunities. Now, PDS programs have been implemented across teacher education in a variety of different ways. We see them in undergraduate education, we see them in graduate education, we see them in single semesters, across multiple semesters, we see them in just in a single course as well as multiple courses within the program. And as we look at the research that's been done, we have seen that it's positively impacted candidates in terms of their self-efficacy, their professionalism, as well as their pedagogical knowledge. Now at USD, our STEM PDS program, we have partnered with a local elementary school, and this school serves grades 2 through 5. And we are doing a single course PDS program at the moment with the hopes of in the future including our math and science methods courses in this as well. But for now, it's just an introductory to educational technology course. It's a 2-credit class, and really the goal of this course is to prepare candidates to use digital technologies and media within their instruction. It's typically taken by sophomores, and we cover a number of different topics in the course. Some of them are, things like digital citizenship, STEM, social media. We talk a little bit about lesson planning, about high order thinking, 21st century skills, and then we go over a number of different emerging technologies that are available to teachers to use in the classroom. Now, there has been an increased emphasis on graphical coding and robotics in this course, and that has grown out of the partnership with our local elementary school. They aren't necessarily identified as a STEM school, but they have a lot of value in terms of STEM and specifically coding and robotics. And that was one of the things when we partnered that they wanted to make sure that we reinforced and supported with what we did with our lessons. And so the teacher candidates that are enrolled in the STEM PDS program, they spend about 12 hours teaching STEM lessons to elementary students throughout the 16 weeks of the semester. Now, we have done some prior research on TPACK in the STEM PDS program, and what we found was that we used a self-reported survey and found that there were significant differences with medium and large effect sizes on all the 7 of the TPACK domains except PK. Now, in this initial study, it was just kind of a pilot just to see what was going on, and we had some kind of larger limitations than what we would hope for. Primarily, we had very small sections, so we had to use multiple sections throughout the year to be able to do any kind of data analysis, and then we did not have a comparison group. So with this study, we're hoping to kind of address some of those limitations to see if we had anything different in terms of results. So our research questions for this study were, are there any statistically significant differences in candidates' self-reported TPACK after completing a STEM PDS program? And were there any differences in candidate TPACK for those enrolled in the STEM PDS program and those not enrolled? Now, to give you some background on our university and our teacher ed program, we have about 450 students enrolled in the teacher ed program throughout or year to year. And this ed tech class that we are working with is one of 3 required courses for program admission. So they have to pass this course with at least a C to be admitted to the program. And then there are 2 formats to the course. One is the STEM PDS section, which is taught, once a week. We meet for 2.5 hours at the local elementary school, and that's where we meet for 16 weeks. And then the other 2 are more traditional campus sections that occur on campus. And to look at kind of how the classes are more or less structured. With the traditional campus format, they meet twice a week for 50 minutes. And generally how the units go in this course is there's an overview of some kind of educational technology topic, so maybe something with media literacy. And then there is also an overview of related digital tools. So maybe we're learning about things like Canva or iMovie or WeVideo, those kinds of things. Candidates will get practice in the classroom through a variety of different activities. They discuss different tools and how they can work in classrooms, talk about different types of assignments, and then candidates actually have the opportunity to apply their knowledge through some kind of assignment or a project that requires their knowledge of both the educational technology topic as well as the tools that have been learned about during the class session. In the STEM PDS format, we do a lot of the same things. We try to cover as many of the same topics as possible, but we do it in a slightly different way. And that is through the lessons that the candidates will teach to the elementary students throughout the semester. Now, for full disclosure, I am the instructor, the professor of the STEM PDS program. And how this typically works is we do a lot of lesson modeling at the beginning of the semester, where I will walk students through the different lessons that they will eventually teach to their elementary students later in that semester. So an example lesson would be we do an obstacle course where we make a tape, like a masking tape obstacle course on the floor, and then we have to code a dash robot to go through it without going over the line. And we focus a lot on measurement and addition, subtraction, those kinds of things in it, as well as a lot of group collaboration. So candidates will have time in the classroom, just us as our university course, practicing, getting to experience the lesson, and then they have the chance to actually plan their own lesson. So I provide them with a model, but then give them some choices over how they're actually going to carry out that lesson. And then they go ahead and plan their lesson, and then they submit it to me for feedback, and I'll assess it, talk to them about this is where we want to be, this is where you are, here's the things you did well, here's some areas where we need to improve, and here's how you could maybe try to improve that. They make revisions that they need to, and then we get into lesson implementation. And the way we do lesson implementation is really, we do it in teaching teams of 2. So there will be a lead instructor that will teach to 2 of the 4 classrooms that we work with at the school 1 week. Well, their partner will be a peer observer. That way they can take notes over what they're seeing, things that seem to be working, things that seem to not be working so well. And then we come back and the next week for the next lesson with the other 2 classrooms, and then the teacher candidate switch roles. So whoever was the lead instructor is now the peer observer, and then kind of vice versa. And then at the end of each lesson, each week, we go ahead and talk as a class. We do some reflection independently first. Then they do it within their peers, talking about any notes that were taken. And then we talk as a whole class, again, identifying what was successful, what wasn't, what questions do you have, what things do we need to improve, what things do we need to not do, like say, give the iPad to a 2nd grader before you've told them what to do. Those kinds of like classroom management things that they didn't realize ahead of time. So as we thought about how we were going to collect data, we thought, let's just go ahead and do a TPACK survey. It's a self-report survey. It has 37 items ranging with a scale ranging from 1 to 7, with 1 being strongly disagree and 7 being strongly agree. It went through validity and reliability testing with alphas ranging from 0.88 to 0.92. And then we collected data at the beginning of the semester and then at the end of the semester. We carried out data analysis using R, and we use mean, standard deviations, period samples t-test, effect sizes, and COVA. And then as far as our participants, a lot of similarities between the 2 groups. So we had 71 students overall, or teacher candidates overall. In the PDS, we had 24, and then in the non-PDS, we had about twice as many at 47. And generally, they were, females, sophomores, Caucasian, traditional college age. Most of them are LED majors. There are a few secondary majors that we have at our university in our program. Some PE majors were in the course as well. We also had a nursing student in the non-PDS section, which was kind of a first, I guess, for us. But generally, these demographics are very similar to what we have just generally at our university. So let's talk about the results. So looking at the STEM PDS candidates, their TPACK differences kind of before and after coursework. So starting, they were kind of at the moderate level of knowledge is what they reported out. And then there were significant increases to the post-test where it went up to into the 6+ range on the scale. And it was all significant with large effect sizes. In our non-PDS sections, their TPACK was very similar. It was, again, kind of in the middle of the scale at the beginning of the semester, and then it went up a bit by the end of the semester. And their increases were also significant from pre to post, and they had medium and large effect sizes. And then our ANCOVA results, controlling for those pretest ratings. So there was a significant positive predictor with the pretest ratings for the post-test responses. However, there was not a significant difference as a result of the enrollment in the PDS program. So what does all this mean? So our first research question that we were trying to answer here was, are there significant differences in candidate self-reported TPACK after completing a STEM PDS program? And yes, for PCK, TPK, TCK, and TPACK, which were the 4 areas that we examined or analyzed, they increased significantly with large effect sizes. So it's an indicator that the STEM PDS experience likely is contributing to candidate TPACK development, and it appears that it's contributing in a way that seems very similar to our traditional on-campus format. Which is good. It's not any less. It's definitely not more, but it's a good sign as we get started with what we're doing with this more or less new program that we've started. And as we think about future research in this area, one thing that we want to start exploring is enacted TPACK and like actual expert ratings of observed candidate knowledge. I think that might be an interesting study to conduct to see how they're actually carrying out their instruction using technologies, because all of our lessons that we teach are very much heavily focused on using technologies. There's always a technology element to our lessons. But what we also want to do is do some qualitative explorations of their knowledge as well. How are candidates making sense out of what they know? 'Cause the numbers through our quantitative research will tell us one thing, but the actual voices of the students or the candidates will probably tell us something different and maybe open up new areas for discovery. And then our second question was, were there any differences in candidate TPACK for those enrolled in STEM PDS and those not enrolled? And what we found was that the STEM PDS candidates had higher means and lower p-values and higher effect sizes. But with the ANCOVA, it indicated that for those 4 areas that we analyzed, there weren't significant differences as a result of being in that PDS program. And this really is begging the question for us, well, what role does the context or the setting specifically have in which our knowledge develops or impacts our knowledge? And really, this is an area where we need more research, and it's something that we're going to definitely start exploring as we move forward. As we look at our limitations, there's always limitations, and one for us is it's self-reported knowledge. It's candidates telling what they think about their own knowledge, so there is some threat to validity there. But then it's also hard to draw conclusions between groups because they were non-equivalent groups. They were different sizes. There was almost twice as many students in the non-PDS sections as there were in the PDS section, so there's some limits to that. And then the candidates themselves, when they register, they could self-select which section they wanted to be in. So it's possible that that influenced the type of students that we had. And then our setting is likely not transferable. We're pretty unique probably in what we're doing and how we're doing it. So other people trying, if they have a STEM PDS or something similar, I'm sure they would probably have slightly different results. And then our sample itself was primarily female and Caucasian. And I imagine if we were in a different setting with different teacher candidates that have different demographics, we might find something different. So that's always something to be thinking about. And with that, that brings my presentation to an end. And I am going to introduce our next presentation, which is by Dr. Yi Jin and Christy Harp, investigating middle grades pre-service teachers TPACK in a teacher education program.
Thank you, Dan. Today I'm going to talk about investigating middle grade pre-service teachers TPACK in a teacher education program. First, I want to briefly talk about why we decided to conduct this research. In the TPACK literature, there are a lot of empirical studies that investigated either elementary pre-service teachers or secondary pre-service teachers. Because if we look at the instrument, we have the TPACK surveys investigating all the content areas for pre-service teachers in the elementary and early childhood education, or they have single content area surveys to investigate secondary pre-service teachers TPACK development. However, if we go to the next slide, I want to say that middle grade teachers are a less research population. We don't have a lot of research devoted to middle grade teachers only in the TPACK literature. So for our research, we want to devote our attention to our middle grade teachers and see how their TPACK developed in the teacher education program. So we have some central questions here. Are there differences in the TPACK attitude, self-efficacy scores of those pre-service teachers? So here we put them in 2 sections. One section is the flipped team-based learning section that use the pedagogy of flipped classroom plus team-based learning. And the other section is the flipped classroom only section. So we have 2 sections here. We want to look at whether there's differences. We also look at their perceptions of teamwork after taking the course, comparing these 2 pedagogies, and we look at their lesson idea scores to see whether there are some differences in their lesson idea scores. Okay, so we go to the next page. So the method we use, we can go to the next page as well. Thank you. So the methods we use here, we use a standalone educational technology course. In this course, we use from TPK to TPACK instructional model for the course design. So here there's a figure to talk about what exactly we call from TPACK to TPK to TPACK. And if you want to read more about this, in the article, I write more about what we mean by this pedagogical model. And the section, as I mentioned, section 1 is using flipped team-based learning pedagogy, and section 2 only use flipped classroom pedagogy. Okay, so we have two sections of middle grade pre-service teachers enrolled in the standalone educational technology course. We have some voluntary participants in this research. Section 1, we have 13 participants, and Section 2, we have 19 participants. Their demographics are pretty much similar to each other, and their pre-TPACK scores are very much similar as well. The only thing is they might have a difference in their concentrations. So in our teacher education program, our middle grade pre-service teachers can go down to higher elementary, so they are prepared for all the content area in the higher elementary grades. And they're also prepared in the middle grades with 2 concentrations. Usually they will pick 2 concentrations, for example, literacy plus social study. Some of them choose 1 concentration like literacy only or social study only. And another popular combination is math plus science. So we could now control who enroll in which section with the concentrations. The only difference is we may not have a very even concentrations in the 2 sections. We use 3 survey instruments for the study, the TPACK pre and post survey, and we also use the attitude and self-efficacy pre and post surveys, and we use TBL team-based learning post survey at the end of the course. We decided to look both the TPACK and attitude and self-efficacy because there are a lot of research in the TPACK field talking about TPACK is not measuring the actual growth in pre-service teachers' technology integration. We also need to measure other variables like attitude and self-efficacy, which are both research-based variables that contribute to pre-service teachers' technology integration. So we decided to look into those 2 variables as well. To balance self-reported data for this research, we also used lesson ideas. We used Judy's TRAR rubric to analyze 200 lesson ideas. So we have 2 researchers for this research, and we blindly reviewed 200 lesson ideas. And then we compared our scores, and we resolved any differences we had. So next, I want to talk about the result of our study. The first one is our first research question. So from our research, we found there were some differences in pre-service teacher self-reported TPACK, attitude, and self-efficacy scores in each of the sections. So if you see our graph here, one is the FTBL section, the other one is the FC section. You can see they all have some growth from the beginning of the course and at the end of the course, especially the self-efficacy variables grew a lot in the course. However, we did not find a lot of statistically significant differences in the variables. We do have a few differences, but not all the variables have a difference. Let's go to the next slide. Another thing we found is for the post scores, most construct scores reported by the pre-service teachers enrolled in the flip team-based section reported higher scores, except for the PCK and effective attitude. But we did not find a lot of statistic significant differences. So from the graph, you can see they are almost identical, but the FTBL section does score a little bit higher than the FC section. Okay, let's go to the next slide. And for this one, we look at lesson idea scores. So we found that pre-service teachers rarely chose grade 5 as their grade level for their lesson ideas. What does this mean? Which means our middle grade teachers, when they're deciding whether to choose elementary grade levels to create their lesson ideas, rarely they decided to go down to the elementary level. As I mentioned before, they were prepared as well to be higher elementary grades teachers as well. But when I give them the freedom to choose to create their lesson ideas, their lesson plans, they rarely go down to the higher elementary level. They stay in the 3 grade levels in the middle school. And another thing we found is they rarely choose math as their content area in the FTBL section. After we look into the concentrations, we found a lot of them are social study teachers, like social study, literature, all of them are concentrated in social sciences. Although they are prepared to teach math for for higher elementary level and some of the middle grades levels, they rarely choose math as their content area. Using independent sample t-tests, we found that in general, pre-service teachers enrolled in the TBL section scored higher in their lesson ideas than those enrolled in the flipped classroom section. One important strategy we used with the team-based learning is to let students form in permanent peer groups, and they do peer review of their lesson ideas every single time when they have an assignment to create lesson idea and lesson plans. So we think maybe the peer reviewing and peer learning contributed to their scores are a little bit higher than the FC section, because in the flipped classroom section, they don't do peer reviews. Okay, so let's go to the next slide. So here I have some discussions I want to talk about for this research. So we found that the active learning pedagogies such as flipped team-based learning and flipped classroom are promising. They're not that, we could not identify or say they have full potential because we did not find a lot of the statistics significant differences, but we do some of the promises from active learning pedagogies compared to our traditional pedagogies used in the standalone educational technology course. However, we want to propose that pedagogies alone might not be enough. We still are missing some of the X factors in this standalone educational technology course. I want to propose what Teresa will present later is the other courses, technology infusion in the entire technology, in the entire teacher education program. Our pre-service teachers only learn technology integration mostly in our course. They learn some part of it in other courses, but we don't have a program-wide technology infusion. So I think that might be our X factor to help them develop their TPACK. And I also want to say that most middle grade pre-service teachers rarely focus on elementary curriculum in designing their lesson ideas, despite higher elementary education is a part of their training. So they have a lot of coursework and a lot of preparation to teach in the higher elementary levels, but rarely they actually create their lesson ideas or lesson plan for those. So I think that's a problem when we are evaluating or trying to see how they develop their TPACK, when they're not doing technology integration in the other content areas despite their own concentrations in the middle grades. That might screw our data a little bit because we're still trying to investigate all their technology integration in all the content areas. And I want to advocate more research should be conducted to focus on middle grades pre-service teachers only, because we have a lot of research for elementary pre-service teachers and secondary pre-service teachers, but as the middle of our sandwich here, our middle grades pre-service teachers deserve more attention as well. So today I only briefly talk about this research. My central goal is to ask everyone to pay more attention to the TPACK development of our middle grades pre-service teachers. If you're interested in this piece of research, our article is in press with the Journal of Digital Learning in Teacher Education. So you can read more in our article. Next, Teresa will present her research on TPACK is throughout technology-infused teacher preparation.
Thank you, Yi. My name is Teresa Folger. I work at Arizona State University. We have been, as Yi kind of prepped all of us, we have been practicing technology infusion at ASU since about 2010, 2011. So we have a little bit of history in trying to move forward in what the National Educational Technology Plan of 2016 calls a program deep and a program-wide effort. The technology plan update in 2017 brought to the education, excuse me, brought the attention to teacher educators that a one-shot approach is probably not a good idea for addressing technology integration for teacher educators. They also asked that every faculty member become involved in an effort to figure out a new solution. So at ASU, we took the opportunity, actually before this plan came out, to eliminate our technology integration course in efforts to present technology across the breadth of our programs. So I just want to talk a minute about the foundational principles of TPACK. And at ASU, we see TPACK as a conceptual framework for helping us understand sort of the messiness and the interrelatedness of these three knowledge bases: technological knowledge, pedagogical knowledge, and content knowledge. And you had some research that came out last year, I think maybe an article pending, and also we've referenced Margaret Neese a lot, her research in math about the pathway to developing TPACK. So at ASU, we took that to mean that it would nearly be impossible in a standalone course if learning to teach with technology is developmental. It would nearly be impossible to teach technology integration in a one-semester course. So in that case, my role as an educational technology faculty member has shifted greatly since this time. You want to take me to the next slide, Dan? Thank you. So recently, we have, let's see, I'm going to talk about stage 3 first in this diagram. So stage 3 is our full vision. And we're not quite there yet. This is a very long process of change. But the line across the diagram represents the curriculum for technology integration as it advances and progresses through the breadth of a program, leading to student teaching, where we want our teacher candidates to become proficient at teaching with technology. What we did last year is we started with some of our own explorations of what we felt were important with teaching technology integration. What were the topics that were of relevance and of importance? And then we also did some alignment processes with content standards for science, math, social studies, language arts, and others. In the end, we came up with 6 categories for technology integration competencies. These are categories of which we want our teacher candidates to be proficient with by the time they graduate, okay? So if that's to take place, as you can imagine, cannot be done in a one-shot standalone course, which is stage 1, as you see on the far left of this diagram. And as we've been trying to function recently, it also probably cannot be done in the 4 methods courses in each of our certification programs. We really need efforts all the way through from everybody, helping teacher candidates learn how to teach with technology. Again, it goes back to the fact that learning to teach with technology is developmental. It requires a lot more than just a hit and miss siloed type effect. So Dan, let's take it one more slide. Okay, there's a lot on this slide, so let me talk you through it. First of all, one of the things we've been doing in our research is using TPACK as a measure. And a lot of us have talked already in this presentation about a variety of instruments. You used the Chia instrument. It seems to me in our lit review I did with Mansu that the Schmidt survey may have been the beginning of some of the TPACK measures that look at the 7 knowledge bases represented in the TPACK diagram. There's sort of an historical view of how this TPACK measure has taken place. It seems like researchers and practitioners needing to measure TPACK have been a little bit, they've seen some deficits in measures of just TPACK. And if you look at the paper, which is the Sue and Folger paper, you can see that historical approach. So last year, Punya Mishra came out with an editorial in JDLTE, and he said that we need to reimagine the contextual knowledge circle in the TPACK diagram. So the diagrams, the 2 TPACK diagrams at the right, the first one is the original diagram that came out in the 2009 or 2006, I believe, JDLTE article. And that dotted line surrounding the Venn diagram says context, but contextual knowledge, as Judy and Jessica did so well demonstrate, was not really taken as a knowledge base by practitioners and researchers. And perhaps it should be, because if we're preparing teacher candidates to teach within the varied and unique contexts that they'll be faced with in their future, and if we want them to stay in the field and be prepared to navigate those uncertainties, it seems like in preparation, we need to do our work to do the due diligence to help them prepare for those contexts and hold true to their beliefs about teaching with technology. So the second diagram that you see is the diagram that Punya put out as a reimagining in his editorial in JDLTE in 2019. And you can see that contextual knowledge is now defined as XK, just from that new diagram. So we took that to heart at ASU, and actually had been already starting to look at a new instrument, article pending. We have validated it, and we're finishing writing it up right now. But we're looking at predictions of teacher candidates' intentionalities to teach with technology. And so what we did is we talked to teacher candidates and said, what are your concerns? What are your beliefs? And in your research, you had behavioral intentions and perceived usefulness. I'm curious about reading about that, because I think that very much aligns with where we are right here. But we're hoping to supplant a measure of not only TPACK, because those are the skills teacher candidates need, those 7 areas of TPACK, but also a more in-depth investigation of our teacher candidates' contextual understandings and their thoughts about how they might be able to navigate context in their future. One of the things that I think poses some interesting future research in this is that if we look at contextual knowledge and define it separately from a teacher candidate, that might be ill-informed as well, because there's a reciprocal interaction when a teacher candidate is a part of that context and things change. So going back, Dan, I'm going to ask you to back up one slide, sorry. Going back, some of the things that we want to teach intentionally in our programs is that leadership capacity, the ability to instill one's own professional learning, right, through all of the resources that teachers now have available to them. How can we as teacher educators supplant some of those competencies in our teacher candidates so that again, when they enter the field as certified teachers, they hold true to what we all have been working so hard for while they're with us, is to teach with technology and continue to lead the way. So with that, I'm going to turn it back over to our facilitator, I believe, Dan.
All right, and that brings us to a close for our symposium. We want to thank you for joining us today, and we will engage with you in discussion online through academic experts in the comments area for this presentation. So we look forward to having interactions with you there. Thank you.